All right, so this is where we finished off yesterday. Yes, because we finished the first problem and we stopped on the second one. So we look at this one here. This is the system of equation we'll be solving first. Now, one of the first things we need to do is to get x, no, not x, but we need to eliminate a variable from all three. Yep. We need to eliminate a variable from all three equations. X, y, or z, which one do we want to eliminate first? We can eliminate z first because it doesn't matter which one, because here with the first one being x, y, z, it's easy to turn x into the other two. It's easy to turn y into the other two, or z. So we can pick any one we want. So we can do z. Now we need to pick our eliminator equation, the equation we're going to eliminate, use to eliminate the other two out. Well, we're going to need to use the first one because that's the only one that we can easily eliminate z out of all three. Questions on this so far? Now we can rewrite the other two equations, 5x plus 5y plus 5z equals 3. And 4x plus y minus 3z equals negative 6. So the two we're not eliminating anything out of. We'll go on and write them down first. Well, in this one here, none of the z's, our eliminator z doesn't match up to the other two. So we're going to need to change it. We're going to need to scale it. So we can take our x plus y plus z equals 2. Bless you. And for the one on the left, we need z to become what? 5z, yes? So we need to multiply both sides of this equation by 5. Well, 5 times x is, 5 times y is, and 5 times z is equals 10. Any questions on this so far? Okay. I'm just going to move that over. Now we can look at the other one. This time we need to multiply the entire equation by what? We can say negative 3 or just 3, because we want the numbers to be the same. We don't necessarily have to have the signs the same. We can. If we keep the signs the same, we'll just need to subtract. So here we can multiply through by 3. 3 times x is x, 3 times y is, and 3 times z is 3z. Now, which one of these two do we want to simplify first? The one on the left or the one on the right? Left. So when we look at this here, we're wanting to eliminate z. Do we add or subtract? So again, if you're not quite sure, we can try one and see if it works. So if we subtracted 5 minus 5, is that 0? If it is, okay, then we're going to subtract all the way across. So we'll start off with x. So 5x minus 5x is 0. They cancel each other out. 5y minus 5y is 5z minus 5z. So that entire side of the equation became 0. Now, up to this point, we haven't written that in for any ones that became 0. We could have said 0x plus 0y plus 0z. But that's all just going to become 0. Even when we had other terms, we didn't write it in because we knew it didn't add anything. But here, whenever everything is 0, we have to write 0 because there is something there. And we need to look at the other side. 3 minus 10 is 0 ever equal to negative 7? Yes. Because as soon as we get this here, at any point, 0 equals a number, a false statement, it is no solution. We stop immediately. Because it really doesn't matter what happens on the other side. All we know for sure is that those two do not intersect. They don't cross. So there is no solution. Questions on this here? All right, let's look at another one. So we're going to look at this one here. Now for this one here, we need to figure out which one we're going to eliminate first, x, y, or z. X. Now we need to pick an eliminator equation. So we're going to use the middle one to eliminate x out of the other two. So we can go on and write the other two down first. So we can say x minus y plus z equals negative 3. And 5x minus 5y plus z equals negative 15. Well, the one on the left, x and x, are they already the same? They both have 1, so we can rewrite it in. Yes. Well, after the last one, it might be good to go on and subtract to see what happens, yes? So this time we will subtract because x minus x is 0. That's exactly what we wanted. So those will cancel. Y minus negative y, negative and negative make a positive, is z minus negative z. The negative and negative make a? You're good. 2z, because we add them together. I mean, the z's sometimes look like 2's. Negative 3 plus, minus negative 3 is going to be 0. Because what times, so when we multiply two things together, yes? 2 times what is 0? That's what it's asking. 2 times what is 0? 0, because anything times 0 is. So here z is. Now for the other one, we can multiply this entire equation by what? 5. So we'll multiply everything by 5. So 5 times x is 5 times negative y is negative 5y minus equals negative 15. So here we need to subtract since we're canceling out x, because we're still canceling out x. So 5x minus 5x is 0. Negative 5 minus negative 5. Negative and the negative make it positive, so it is z minus negative 5. Almost, because the negative would make plus. So z plus 5z is negative 15 minus negative 15 is. So z is equal to. Already got that. So, well, we normally would work backwards, but do we have any equations with two variables? All we've done for certain is say that z is 0. Okay. I'm going to erase all this here. Well, let's pick the first two. Because we know one of the variables. Z is what? Z is 0. Well, I can plug that in, which would tell me that the first one, x minus y is, the second one is 5x minus 5y is. These two here, are they the same? What happens if I multiply this one by 5? 5 times x is what? Which is the same as this one here, yes? This is all real solutions. Yeah, that one worked out kind of weird, but I think y'all are the first group that, well, y'all are the first group that picked x. The other two picked z. No, not too much. But if you look at the z's, what's the number in front of each one? 1, right? So they already all matched up. So we didn't have to do anything to it. But we end up coming to the same exact answer. A little bit, not too much. Questions on this here? Now, there are equations that we could get to define it, but we're not going to go that far into this. So whenever you do get a true statement, because essentially that's what we would end up getting is a true statement. Now, I'm going to show you all this one with, I'm going to pick the topic, not top, let's do middle one for our eliminator and do it with z. No, I'm picking. No, it's easier to do this one. Now with the middle one, we do this here. Now since the signs are opposite, we would add. And when we look at this here, well, for the first one, 5x plus x is 6x. Negative 5y minus y is negative 6y. Z minus plus negative z is 0. And negative 15 minus 3 is negative 18. So if we eliminated z, this is what we get. On the other one, x plus x is negative y plus negative y is minus 2y. These cancel and equals negative 6. So these are the two equations we get. So we didn't, unlike when we eliminated x where we just got z equals 0, we have this here. Now what we can do next is multiply this by 3. Because 6x minus 6y equals negative 18. 3 times 2x is 3 times negative 2y is negative. And negative 6 times 3 is And so if we subtract 6x minus 6x is negative 6y minus negative 6y is, and 18 minus negative 18 is true statement. So we get all real solutions. So that's another way we can see it. Does that make sense? This one I feel makes, when we get this kind of solution, it makes a little more sense. But whenever we get 0 equals 0, so if one of the sides gave us 0 equals 0, make sure to check the other side. It's just because one of these, instead of getting this side gave us 0 equals 0, if this side over here gave us 0 equals 4, then it's no solution. If it gives us an equation, so if this side was 0 equals 0 and we get this on the other side, it's still all real solutions. It's just this is the equation that defines that line where they intersect, where the three intersect.
So it's all real solutions. It's not like
any point that's technically defined by the equation works.
so they're all equal.
There's a line or an equation where they do cross. And we can define it given the certain parameters to it. Because I want this to be the same as. Any other questions on this here? Now, I'm going to let y'all use the rest of the class time to start working on the assignment. So that if you do have questions, you can ask, and I'll go around and answer them.